Hi, in today's video we're going to consider water when it acts as an acid. So two water molecules can come together, one of them acting as an acid, losing its H plus to the other water molecule as shown here, and this reaction is known as the auto-ionization of water. It's very similar to the standard acid reaction of a general acid, HA, plus water going to A minus plus H3O plus. And for that reason, we can consider its Ka. The Ka of H2O is going to be the the concentration of the products, which are OH minus in this case, concentration times the other product, H3O plus, divided by the acid concentration. That's what you need for a Ka. In this case, the acid itself is H2O. And that has a known value of 1.82 times 10 to the minus 16th molar. Practicing chemists actually never use this Ka. Instead, we use an equilibrium constant called Kw, which is the OH minus concentration times the H3O plus concentration. The concentration of water in an aqueous solution is more or less constant. We just factor that in, and we get the answer that Kw is 1.0 times 10 to the minus 14 molar, and that is the number that is typically used, 1.0 times 10 to the minus 14. So it's a very weak acid, but it can act with an acid, and we'll consider a problem where it's acting as an acid. We're going to consider a 0.1 molar HPO4 2 minus solution, and the Ka for HPO4 2 minus is it's a weak acid too, 4.3 times 10 to the minus 13 molar. And so they can both be predominant acids, both the water itself and HPO4 2 minus. So when we set up the problem, we're going to have the two reactions, HPO4 2 minus plus H2O going to PO4 3 minus plus H3O plus. And we'll have also the other reaction, the auto-ionization of water reaction, where we have two H2Os going to OH minus plus H3O plus. And if we look at the E line of the ice table for both, we're starting off with 0.1 molar, so it's going to be 0.1 minus the dissociation of this acid, and this first reaction will produce X amount of H3O plus, and the second reaction will also, the auto-ionization will also take place with a different variable Y. It will also produce some acid H3O plus, so it's going to be YX plus Y. And so we have then the two expressions, X squared divided by 0.1 minus X equals the Ka, 4.3 times 10 to the minus 13. And the other expression, Y times, oops, I made a mistake there. It's X plus Y here. So in the numerator we have X times X plus Y. And here we have Again, we have x plus y is the H3O plus concentration, and that's equal to 1.0 times 10 to the minus 14 kW. And pause the video, please, and see what progress you can make on solving this problem. We're going to start off with orders of magnitude. Okay, good. So we know that the order of magnitude of Ka for this reaction is the HPO4 2 minus is minus 12.5. And that's a very tiny number, so the order of magnitude of 0.1 minus x is going to be unchanged by the x, it's going to be minus 1. We can see that the acid is in fact stronger than the HPO4 2 minus is stronger than the water, and so probably the more predominant of the two acids will be the HPO4 2 minus. And so with that, we can see then we have minus 1 as the order of magnitude here, and minus 12.5 is the order of magnitude here. If we say that both x's are the predominant term of the two, we're going to end up with minus 13.5 divided by 2, which is the order of magnitude of x is going to be around minus 6 3/4. And I'm going to keep the quarter mark. We don't have to, just so we can distinguish a little bit better the strength. So if x is of that order of magnitude, pause the video again and see if you can complete the problem. Good. So what we need to do is figure out the magnitude of y. We know that here it's minus 14 on this side. X is minus 6 3/4. And that means that y has to be minus 7 1/4, because 7 1/4 plus 6 3/4 is 14. So the order of magnitude of y is minus 7 1/4. And so now we can go ahead and see what simplifications we can make. 6 3/4 is much, much less than 0.1, so we can eliminate this term. And we end up with the two equations. I'm going to take this 0.1 and bring it over here. So I'll have x times x plus y. When I bring that 0.1 over, I get 4.3 times 10 to the minus 14, 10 times smaller. And the other is unchanged. Y times x plus y equals 1.0 times 10 to the minus 14. Pause the video to finish the problem. Great. So if you look at these two, you notice that we can divide the two reactions from each other. And if we do that, this portion cancels. And these two cancel also, the 10 to the minus 14. And we end up with x plus y. X divided by y equals 4.3, and then we can solve, and we'll find that x is 1.84 times 10 to the minus 7 at the order of magnitude we predicted, minus 6 3/4, and we'll get the y is 4.4 times 10 to the minus 8, very much in line with the order of magnitude that we predicted here of 7 1/4. And so that's an example of using water, which is a very weak acid, but in the presence of another fairly weak acid, it also can be a predominant acid, and both were predominant in this case. And we'll do an example of this in tomorrow's workshop.